Welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. Now we want to discuss about the classical mechanics. Already I told you mathematical methods of physics according to your CSIR and GATE curriculum. Similarly, total 9 papers we have. Already I told mathematical methods of physics. The second paper is classical mechanics. Each and every paper I will upload you. What are the important questions, how the question paper pattern is there, and how the questions are coming, last year questions, those things we are discussing now. In the same way, now also classical mechanics, according to CSIR and GATE, classical mechanics, it contains the syllabus, prepare a paper pattern and selection solutions of some old questions, right? Now we have to see. CSIR, 2 parts are there in CSIR examination. Okay. According to our syllabus also 2 parts are there. Part 1 and part 2. So what is the part 1 and what is part 2 you have to see. In part 1, some core syllabus is there. In part 2, some advanced syllabus is there. Each and every paper also. In classical mechanics also, some core paper is there, some advanced paper is there. First core paper we have to see. What is the core paper? CSIR part A core paper is classical mechanics. Part A, what is the syllabus is there, you have to see. Newton's laws, Newton 3 laws are there. Newton the first law, second law, third law. First law we call it as a Newton's law of inertia, second law we call it as a Newton's law of motion, third law we call it as a Newton's law of reflection or reaction and reaction, action and reaction law. Dynamical systems, in dynamical system, phase space dynamics, stability analysis are there. Central force motions, 2-body collisions, scattering in laboratory and center of mass frame, rigid body dynamics, moment of inertia tensor, non-inertial frames and pseudo-forces, variation principle, generalized coordinates, Lagrangian and Hamiltonian formalism, equations of motion, conservation laws and cyclic coordinates, periodic motion, small oscillations, normal modes, special theory of relativity, Lorentz transformation, relativistic kinematics and mass energy equivalence. Here you have to see Newton's laws. This is the first one. Next, dynamical system. This advanced part also same syllabus is there. Next, central force of motion, 2-body collision, right? Rigid body dynamics, variational principle, Lagrangian and Hamiltonian, next periodic motion, special theory of relativity. So these many topics are there in core A, right? From core A, sometimes 3.5 marks questions will arise, sometimes 5 marks questions also will arise from this. Now we have to see part B. What is the part B? CSIR part B, this is advanced one. Advanced one means your people have to write the CSIR examination for to do the research or to tell a degree college lecturership exam purpose or to become as a lecturer. You have a great orientation to teach the students, undergraduate and postgraduate students. That's why they want to analyze your skills. That's why the standard of questions, advanced standard of questions, somewhat high, right? Now you have to see. In classical mechanics part B, dynamical systems are there now, same syllabus, phase space dynamics, stability analysis. So these 3 parts are same, right? In part A is there, in part B also is there, subsequent part B also added. Next, Poisson brackets, canonical transformation, this is very important one. Symmetry, invariance, Northern theorem, and Jacobi-Hamilton-Jacobi theorem. This one is some little topics are there in part B, classical mechanics, right? How the pattern is there in exam pattern, CSIR exam pattern, already in mathematical methods of physics also I told. Here two section, part A, part B, part C we have. In part A, maximum number of questions 20. Those questions belongs to which one it is? General aptitude questions. General aptitude questions with emphasis on logical reasoning, graphical analysis, analytical and numerical ability, quantitative comparison, series formation, puzzles. Like that they will ask total general aptitude questions, right? So how many questions came? 20 questions. How many marks for each question? 2 marks. How many questions you have to attempt? 15 questions you have to attempt. For each and every wrong question, you will lose 0.5 marks. This is a part A for all paper. Now part B. Part B, 25 questions are there for CSIR. 20 questions you have to do. Each and every question 3.5 marks. Negative is 0.875. Clear? Now part C. 30 questions the total. You have to attempt 20 questions. Each question carries 5 marks. This is very, very important. If you know the 20 questions for 5 marks question, you will get the 100 marks. With 100 marks, you can get CSIR, you may any reservation. Any reservation means whether you may OBC, SC, ST, PHC, any reservation if you have, then you may get this one. How each and every wrong question, you lose 1.25 marks. Total 75 questions are there. 55 questions only you have to attempt. 200 marks is there. This is the exam pattern of CSIR exam pattern. Please concentrate on exam pattern also. Now the GATE. In section 1, that is a mathematical methods of physics. In section 2, section 2 is a classical mechanics. Which one it is? Classical mechanics. Classical mechanics. Classical mechanics. Syllabus I pasted, but heading, same heading I kept. Now classical mechanics. In the classical mechanics, Lagrangian formulation is there. In Lagrangian formulation, D'Alembert's principle, Euler-Lagrange equation, Hamiltonian principle, calculation of variations, symmetry and conservative laws, central force of motion, same topic is there. Kepler problem and Rutherford scattering, small oscillations, coupled oscillations, normal modes, same. Small oscillation also, periodic motion is there. Rigid body dynamics, in CSIR also the syllabus is there. Inertial, tensor, orthogonal transformations, Euler angle, torque free motion of the symmetric top, Hamiltonian and Hamilton's equations of motion, Leibniz theorem, canonical transformation, action angle variables, Poisson brackets, Poisson bracket, there also is there. Syllabus, Hamilton-Jacobi equation, in CSIR also the syllabus covered. Special theory of relativity. So in special theory of relativity, Lorentz transformation, relativistic kinematics, mass energy equivalence. Somewhat entire the portion is there, whatever the in CSIR syllabus is there, no, except symmetry, entire portion is there except symmetry. Symmetric top is there, but except symmetry, invariance, so those topics are not covered. Except symmetry, entire the syllabus is there. Here you have to see symmetry, invariance and Norton theorem. Except this, dimensional analysis, phase-space dynamics and the stability, dimensional analysis, phase-space dynamics and stability, that one is not there. But there some symmetry and conservation laws, from that we have to get the questions in GATE also from dynamical system. So that part also questions are coming. From this part also questions are coming in GATE examination, right? Rest of the thing, every two body collision is there, rigid body dynamics is there, Lagrangian, Hamiltonian, formalism is there, periodic motion, special theory of relativity. Every syllabus is covered except symmetry, invariance and Norton theorem, right? Now, you have to see once what is the thing, GATE exam pattern. What is the exam pattern? General aptitude. General aptitude, total 15 marks. You have to get, this is the marks, total 15 marks. For 1 to 5 questions, you will get 1 mark for each question, right? For 6th to 10th question, you will get 2 marks for each question. Total how many? So, total 10 questions you will get, only you have to get the 15 marks from general aptitude. General aptitude, there also same. Wherever you have to prepare in CSIR paper 1, here also same is there. General aptitude, 15 marks weightage is there. That is the general aptitude question. 1 to 10 questions are there. Here 1 mark question, 2 mark questions are there. In CSIR 3.5 questions and next 5 marks questions are there. In part A 2 marks is there. Variation is like that. Now in physics, 85 marks for physics. 85 marks for physics, right? In GATE, 85 marks. There 3 variety of questions are there. One multiple choice questions, MCQ questions. The second variety is multiple select questions, multiple options you have to select, numerical answer type questions. Numerical answer type question. You have to enter the numerical value. What is the value? That number you have to enter. So 3 varieties of questions are there. In GATE, in CSIR you have to see. In CSIR from physics, out of there here 15 questions we have to do. 15 into 2, 30 marks. 30 marks for general aptitude. 30 marks for general aptitude. Next, here 100 marks for part C. Here 70 marks. 70 marks for which one? It is 70 marks. Here 100 marks. 70 plus 100, 170 marks. 170 marks only for physics. There in CSIR. Here only 30 marks is there. Here same weightage, but some alteration is there. You have to remember. This is the pattern. 2 patterns are different. For CSIR, 3 varieties of choices are there. In GATE, only 2. One is general aptitude, another one is physics. In physics, 3 varieties of questions are there. Multiple choice questions, multiple selected questions, numerical answer type question. 3 varieties of questions they will ask. Now the reference books. Which book we have to refer for CSIR examination? Right? Now take the classical mechanics, Herbert Goldstein, classical mechanics, G. Aruldas, an introduction to mechanics, Kepler and Kolenkov, and Lagrangian dynamics CAM series also you have to take. Classical mechanics, John Michael Finn. Any one book you have to take. For problems purpose you have to bring this one. Lagrangian and Hamiltonian CAM series you have to take. More problems are there in this book. Clear? Now we will go for how we have to segregate. Once you have to see the syllabus. Syllabus is more, right? A big syllabus we were unable to cover. Correct? Unable to cover. This is a big huge syllabus is there. That's why you have to segregate, like part by part you have to segregate. When you have to segregate the part by part, that time you may get this subject is easy, right? So how many parts I segregated once you have to see. 10 parts I segregated. How I am segregated in mathematical methods of physics. The similar passion in classical mechanics also I segregated into 10 parts. First, Newton's law of motion. From Newton's law of motion, you have to get only 3.5 question, 3.5 mark question in CSIR. 1 mark question. For gate, you may get the choice. Next, dynamical system. In dynamical system, phase space dynamics and stability analysis questions are asking. One 5 marks question, one 3.5 marks question they are asking. So sometimes they may get 3.5, sometimes they may get 5 marks also. 2 marks question you get in gate examination. Central force motions. Central force motion is very important. One 5 mark, one 3.5 marks question they may ask in CSIR examination. In gate examination also, you will get the 2 marks question. Suppose you have to take a rigid body dynamics. What is the rigid body dynamics? 2 questions you get in rigid body dynamics. Two question, 5 marks question. That is the 10 marks for CSIR, 2 marks for gate. Next, variational principle. From variational principle, you may get 3.5 marks and 1 mark for gate. Right? Now, Lagrangian Hamiltonian formation. It is very important. 10 marks for CSIR, 2 marks for gate. Periodic motion, 3.5 marks. Compulsory one question will come for 3.5 marks. Otherwise, 5 marks question also you may get. From gate also the syllabus is there. In there also you are getting. Special theory of relativity. It is a very important topic. Special theory of relativity. From special theory of relativity, pakka you will get 3.5 or 5 marks question, 2 marks in gate examination. Next, Poisson bracket and canonical transformation. There also you will get the 5 marks question and 2 marks for gate. Symmetry, invariance, Norton's theorem, Hamiltonian Jacobi theory is there. From Hamiltonian Jacobi theory, so 2 marks for gate. Gate syllabus is there, but this syllabus is not covered in CSIR. So gate examination. 3.5 for CSIR. Only one topic is there. That topic only not covered in CSIR. Entire the classical mechanics, whatever you read for CSIR examination, that will help in gate examination also. Clear? Gate also very good exam to enter into the IIT or NITs or ICERs. Nowadays, if you want to go for the PSU as a permanent job purpose, you need the gate score. Now, from each and every area, I segregated into 10 areas. Newton laws of motion, dynamical systems, central force motion, rigid body dynamics, variational principle, Lagrangian and Hamiltonian formalism, periodic motion, special theory of relativity, Poisson brackets and canonical transformation, symmetry, invariance and Norton theorem, Hamilton-Jacobi principle. I segregated in 10 parts. So within these 10 parts, 10 important questions. Whatever the previously they are asking in CSIR gate, those questions I brought and I am explaining to you, because this is all my demos. Once you have to see. First this question, first topic, from first topic I took this question. A solid cylinder of height h. Suppose you have to take a solid cylinder. It is the cylinder, right? You have to take a solid cylinder of height. How much height is there, Nana? H height is there. You have to take the solid cylinder height is h. What is the radius of this cylinder? That cylinder radius is r. That density, so the density of the cylinder, if you have to take the density of the cylinder is rho. Density of the cylinder is rho. Floats vertically on the surface of a liquid. Vertically, liquid is flowing, right? So what is flowing? With what density? Rho naught density. Vertically, surface of a liquid is flowing rho naught density. The cylinder will be set into oscillations. This cylinder is now is setting into oscillations. It is moving this side and moving to this side. Setting into oscillation. When a small instantaneous Dowd force is applied, what we have to apply? a small instantaneous down force, a small instantaneous down force is applied, the frequency of the oscillation, which oscillation? Whatever the liquid is flowing in the cylinder, that oscillation they are asking. Clear? So this is the problem. When they are asking, December 2012, CSIR people are asking for 3.5 marks question. This is a 3.5 marks question. We have to check also, no problem. Now you have to see how we have to solve, which answer is suitable for this. How we have to solve this one? For solving this, which process we have to follow? Newton's second law. From Newton's second law of motion, the external force MA, this is the external force, MA is equal to something is that is a Fg is there, this is Fg, this is the gravitational force, that is mg, the weight of that cylinder towards the downward side. If now I am applying this is external force, which one it is? External force. There is a equivalent, this is the oscillator is there. That's why there is a equal and opposite force is working. That equal and opposite force, which one we have to take, Nana? Minus, we have to take rho A G H. Minus rho G A H. I have to take. So what is the rho A G H? How much height is there? That height, so you have to consider as a small h, you have to take from here to here. So that h you have to consider, right? Now you know one thing, this m is belongs to whom? This m is belongs to the cylinder, right? So mass is equal to, which one we have to write? Density of the cylinder into volume of the cylinder. Density into volume is equal to, which one I have to write, Nana? Volume is equal to area into h we have to write. This is m is equal to rho ah. From this you have to substitute this value rho ah into a is equal to, here we have to write here which one? This is the liquid. That's why rho naught ah into g, rho naught ah into g minus, which one we have to take, Nana? This m, rho m as it is you have to write this one. You have to write here rho ah. This one you have to take as a rho naught. This part is belongs to the liquid force upward side, liquid force, which side you have to take? Upward you have to take. That's why you consider as a rho naught a g h you have to take. Here rho naught a g small h we have to take. From this you get the cancelling, a is there, you cancel it. Next a is equal to, you have to take here rho and h, this side rho h g is divided by rho h minus rho naught g h is divided by rho h. You have to cancel the rho h cancelled it. Here any cancel terms are there? There is no cancel terms. What are the thing is remaining? That one you have to take. A is equal to g minus rho naught into gh is divided by rho into h. This h value I want to bring this side. How we have to write? A by h is equal to g by h is equal to, so g by h is equal to minus rho naught into g, minus rho naught into g is divided by rho h we have to write. Clear? Rho naught into g is divided by rho h. Here a by h acceleration by some height upward direction. Here a gravitational acceleration by some height, omega square is equal to external frequency is equal to, this is a weight of the frequency, omega downward side frequency square minus which one it is, this is the water liquid, whatever the liquid is there, that liquid is an oscillatory frequency, that liquid frequency is equal square. So omega naught, you have to compare this, value, right? Omega square is equal to rho naught g by rho h. Therefore, omega is equal to square root of rho naught g by rho h. This is your answer. Angular frequency of the oscillation is equal to rho naught g by rho h. What is your option? Option D is correct. Like this, you have to calculate this question from whom? This question from Newton's law of motion question. It is some difficulty question is there. CSIR people will ask like that only to test your knowledge, the purpose they are asking like that. It is a advantage question. Now second, what is the second one? Which one we have to take? Once you have to see here. The second one is a dynamical system, phase space dynamics. In phase space dynamics, from the dynamical system, they are asking the question, GATE 2000 question, I took this one. The phase space trajectory of an otherwise free particle bouncing between two hard walls. What is the thing? Once you have to see, first you understood the question. Two walls are there, these are the walls. One free particle is bouncing, free particle, this particle is free, right? Which particle it is? Free particle. This free particle is bouncing between the walls, hard walls, elastically in one dimensional. This is a 0 to L box length, right? Now we have to calculate the phase space trajectory, the path of that bouncing particle they are asking. How we have to calculate? Whether it may be straight line, whether it may be parabola, whether it may be rectangular, whether it may be circle. Which answer is correct they are asking. First you have to calculate the energy value. How we have to calculate the energy? First we have to calculate the energy. The total energy is equal to kinetic energy of the particle P square by 2m plus potential energy of that particle. With that particle is a free particle, 1 by 2 kx square. This is the potential energy of that particle. Clear? Now, E is equal to, we are rearranging P square by 2m plus x square is divided by 2 by k. I am writing x square is divided by 2 by k. I am again rearranging. How I am rearranging? Once you have to see, this E I am bringing into this numerator side. 1 is equal to P square by 2m E plus x square is divided by 2e is divided by k. Again I am changing this one. How I am changing? Once you have to see, 1 is equal to x square by square root of 2e by k whole square plus y square means p square. P square is divided by square root of 2me whole square. Can I write like that? X square by a square plus y square by b square is equal to 1. Which one it is? It is a x square by a square plus y square by b square is equal to 1. Which equation it is? It is a, which equation it is? It is elliptical equation. Which equation it is, Nana? Ellipse. This equation is elliptical equation. Elliptical equation, right? This equation is elliptical equation. So this is elliptical equation. We have to take the options are, all options are wrong options I gave. you have to take the C is a ellipse, you have to take elliptical, right? Elliptical trajectory. Suppose you have to take the trajectory, how we have to write the trajectory once you have to see. This is a x-axis, this is px axis, this is which one it is? It is a phase space dynamics. If it is x is equal to 0, when it will happen, this plus 2me it will happen. If it x is equal to 0, you have to get minus 2me also, right? There is a two possible. If px is equal to 0, you will get the minus 2e by k you have to get. Here plus root 2e by k we want to get. If you have to add this path, which path it is? This path is a elliptical path, right? In the option you have to see, this rectangular is not correct, you have to take elliptical path. This question is 2017, they are asking in GATE examination. They will ask like that. It is from which area? It is a phase space area, dynamics of a phase space, right? Now I am going to the third one. It is very, very important question. Once you have to check it. Consider the circular orbits in a central force potential. So one orbit, consider a circular orbit. We have to consider the circular orbit, central force of motion. How much potential is there? So V of r is equal to, in the circular orbit, V of r is equal to minus k by r to the power of n, where k is greater than 0, that is a positive constant, and n is belongs to 0 to 2, in between the 0 to 2, 0 is less than n, is less than 2 is there. If the time period of the circular orbit of radius r is t1, if you have to take a radius r, then time period is equal to t1. Then that of the radius of 2r, if you have to take a 2r, that time period is equal to t2. Then t2 by t1 is equal to how much? T2 by t1 is equal to how much? This question so many times, so many exam people are asking. This question came in Gurukula examination also. Gurukula exam people also asking. Maybe that exam is JL or DL. Which exam exactly I don't know. But Gurukula people are asking in recently. TSPSC. Gurukula set people are asking in Telangana. Right? Now you have to see in CSIR. This question is a December 2016 CSIR question. What is this? This question belongs to central force motion. Central force motion question. Now you have to see. The effective energy under a circular path, V effective is equal to, the effective energy is equal to rotational kinetic energy. That rotational kinetic energy is equal to J square is divided by, what is the rotational kinetic energy? J square is divided by 2m r square plus potential energy. What is the potential energy? Already they are given the potential energy. V effective is equal to J square by 2m r square minus, what is the potential energy, Nana? K by r to the power of n. This is the effective potential energy under the central force in a circular path. This potential energy we know now, this energy we know. First we have to calculate the first derivative with respect to r. Though effect in the central force, though effective by though r is equal to 0 under central force. Which one we have to take? Under central motion, periodic motion, circular motion we have to take though V effective by though r is equal to 0. How we have to get? Once you have to see here, we know that one. Which one we know, Nana? We know V effective is equal to j square is divided by 2m r square minus k by r to the power of n we know, correct? K by r to the power of n. First, what we have to calculate? First derivative, dou effective by dou r we have to take. Dou effective by dou r is equal to which one we have to write? J square by 2m is a constant minus 2 is divided by r cube minus k is divided by minus n is divided by r to the power of n plus 1. Which one we have to write? This is equal to 0. 0 is equal to minus 2j square is divided by 2m r cube minus into minus plus n into k is divided by r to the power of n plus 1. 2 1 ja 2 1 ja get cancelled. Now you have to bring this value here. J square by m r cube is equal to nk is divided by r to the power of n plus 1. Nk is divided by r to the power of n plus 1. Now j is equal to which one we have to write, Nana? J is equal to m r square omega. J is equal to m r square omega. From that, what we have to write? You have to see j square means m square r to the power of 4 omega square is divided by m r cube is equal to nk by r to the power of n plus 1. 1 r cube, r is get cancelled. 1 m get cancelled, right? So which one we have to get, Nana? M omega square is equal to nk is divided by this r we have to write r into r to the power of plus 1, right? Omega square is equal to nk is divided by m r to the power of n plus 2. Omega square is equal to which one we have to write, Nana? Omega square is equal to n r to the power of, therefore omega is inversely proportional to, which one we have to write? Omega is inversely proportional to 1 by r to the power of, so root r to the power of n plus 2. So root r to the power of n plus 2 I have to write. Omega is equal to 1 by root r to the power of n plus 2. Not yet completed. Again one thing is there. Omega is equal to 2 pi by t. Therefore, so omega is equal to which one we have to get, Nana? 1 by r to the power of n plus 2 is divided by 1 by 2. So which one we have to take? Omega is inversely proportional to r to the power of n plus 2 by 2 we have to get. But t is equal to, it is a reciprocal. Reciprocal means, therefore r to the power of n by 2 plus 1 we have to write. T is inversely proportional. But what they are asking? They are asking about the T2 by T1. T2 by T1, how we have to get? T2 by T1 is equal to, how we have to get, Nana? 2 by r. T2 is equal to 2r to the power of n by 2 plus 1 is divided by T1 is equal to r to the power of n by 2 plus 1. So now r get cancelled. Therefore, T2 by T1 is equal to 2 to the power of n by 2 plus 1 we will get. What is your option? Your option T2 by T1 is equal to 2 to the power of n by 2 plus 1, right? Once again we will check the option. There is their option C is correct. 2 to the power of n by 2 plus 1. T2 by T1 is equal to, which one is equal to? T2 by T1 is equal to 2 to the power of n by 2 plus 1 is there. This is the option is correct. Clear? Right. Now we will see the next question. What is the next question once you have to take? The number of degrees of freedom in rigid body dynamics. This is a rigid body dynamics question. Very, very important. So many times your people are asking, if it is a d-dimensional, which dimensional? D space dimension. If it is a d space dimension, the degree of freedom is equal to the degree of freedom. The degree of freedom is equal to d into d plus 1 is divided by 2. This is the degree of freedom for a d-dimensional. Right? What is the option? Option C is correct. Directly you have to do this one. Fourth one, directly you have to do. This question is degree of freedom. Most of the time from parallel axis theorem, perpendicular axis theorem, or otherwise that moment of inertia questions, direct formulas they are asking in CSIR also from rigid body dynamics. Now we will see a particle is moving under the action of generalized potential. What is the generalized potential, Anna? Generalized potential they are giving V of q comma q dot is equal to 1 plus q dot by q square is giving. This is the generalized potential. The magnitude of the generalized force they are asking. Which one they are asking? Generalized force they are asking. You know the Lagrangian equation of motion. What is the Lagrangian equation of motion? D by dt of dou L by dou Qi dot, dou L by dou Qi dot minus dou L by dou Qi is equal to 0. There, what is the generalized force? The generalized force is Fq is equal to minus dou L by dou Qi. Already dou L by dou Qi. So here generalized potential is there. That part you have to substitute here. Fq is equal to minus dou by dou Q of which one you have to take? 1 plus Qi dot is divided by Q. Where 1 by Q is there, that's why which one you have to take? Fq is inversely proportional to, so 2 by Q cube you will get. This is the option. Option C is your correct option. This is the generalized system. From fifth one, whatever the fifth one is there now, variational principle. From the variational principle, I have to take this question. Once you have to see here, which one it is the variational principle. Generalized coordinates and variational principle is there. From that I have to take one. Just a simple one. This is very, very simple. Easy to you have to find. Now, one more important one. The Hamiltonian of one-dimensional system. They are giving the Hamiltonian of one-dimensional system. What they are giving? H is equal to x into p square by 2m plus 1 by 2 kx. 1 by 2 k. This question CSIR June 2018. June 2018 time they are asking this question. Where m and k are positive constant, the corresponding Euler-Lagrange equation of motion they are asking. First Lagrangian we have to calculate, then equation of motion we have to calculate. So we are taking a Hamiltonian. First Hamiltonian we have to take. So next page I have to take. Fresh page I have to take. Once I have to do this one. Once you have to see what they are giving. Hamiltonian. Xp square is divided by 2m plus 1 by 2 k into x they are giving. This is a Hamiltonian. To calculate the Lagrangian, to calculate the Lagrangian, how we have to calculate the Lagrangian? To calculate the Lagrangian, L is equal to P in a summation of Pi into Qi dot minus H. So this is the Lagrangian or Hamiltonian or Lagrangian you have to take, right? From this formula, how we have to calculate once you have to see. How we have to calculate. First, we have to calculate this one. First, Lagrangian we need to calculate. Here Q is equal to X. X cap we have to calculate. X cap is equal to dou H by dou P. X cap is equal to which one we have to write, Nana? dou x by dou p. So dou h, dou by dou p of, this is a Hamiltonian equation. From the Hamiltonian equation I am finding dou by dou p of h value I am writing. X p square is divided by 2m plus 1 by 2 kx. 1 by 2 kx. You have to differentiate. Which is the p is there? Here only p is there. Therefore, x by 2m into p square is equal to 2p, correct? Therefore, 2 1 get cancelled. X dot is equal to xp by m we have to get. Which one we are getting, Nana? X dot is equal to xp is divided by m we are getting. X dot is equal to xp by m. From this you calculate the p value. P is equal to m x dot is divided by m x dot is divided by x we are getting. Clear? M x dot is divided by x. Now you find the Lagrangian. L is equal to there p you have to write where p into x dot minus h. This is the Lagrangian equation. Now you calculate and now. So which one you have to calculate? That value you have to substitute here. P into x dot minus h. P into x dot h is equal to, what is the h? X into p square is divided by 2m plus minus 1 by 2 into kx. This h value I am substituting. These two values from where I am taking? From h value I am taking. This is a L is equal. Now already I calculated x dot. That x dot value how to substitute. So x dot is equal to, otherwise you have to substitute p value how to substitute. P value how to substitute. What you are getting once you have to see. I am eliminating the L is equal to p value. M x dot is divided by x into x dot. This p value I am substituting. Minus x into x by 2m into, which one we have to write? M x dot is divided by x whole square minus 1 by 2 kx we have to write. Minus 1 by 2 kx. Now I am simplifying. L is equal to m x dot square is divided by x minus, so which one we have to write, Nana? M square x dot square is divided by x into 2m x square minus 1 by 2 kx. Here you have to cancel it. 1x get cancelled. 1m get cancelled. Here you have to see what are the value is remaining. That value you have to write. L is equal to m x dot square by x. This is the one value. M x dot square is divided by 2x minus 1 by 2 kx. Right? 1 by 2 kx. Therefore, you have to subtract this value. 1 minus 1 by 2 is equal to 1 by 2. Therefore, m x dot square by 2x, m x dot square by 2x minus 1 by 2 kx. This is the L value. If you know the Lagrangian, what they are asking? Equation of motion of a Lagrangian they are asking. How we have to calculate the equation of motion of a Lagrangian? We have to calculate the equation of motion of a Lagrangian. Equation of motion of Lagrangian is equal to d by dt of dou L by dou x dot minus dou L by dou x is equal to 0. This is the principle. What is your L? L now only we calculated. L is equal to m x dot square is divided by 2x minus 1 by 2 kx. Now you substitute the value here, right? D by dt of m, d by dt of dou L by dou x dot, dou by dou x dot of Which one we have to substitute, Nana? M x dot square is divided by 2x minus 1 by 2 kx, correct? 1 by 2 kx, bracket close, minus dou L by dou x, into, which one we have to write? This L. M x dot square is divided by 2x minus 1 by 2 kx you have to substitute. Now you is equal to 0. You simplify this expression. How we have to simplify? Once you have to see d by dt of, first you have to differentiate with respect to x dot. Here no x dot, so that's why the entire thing is equal to 0 it will come. Here one x dot is there. Which are the constant? M into 2x is the constant. That's why you have to take here m by 2x into x double dot. Which one it will? X dot square, x dot into, first you have to take to x dot square, you have to differentiate 2x dot into x double dot is there. 2x dot into x double dot, correct? 2x dot into x double dot you have to do first. That one you have to do, right? So L is equal to, so that one you have to do plus 2x double dot, that entire thing is 0, minus dou by dou x of this x dot is there, that's here one thing is there, minus m x dot square is divided by 2 into, which one? Minus 1 by x square is there, minus 1 by x square, minus into minus plus. Here you have to take 1 by 2 k, you have to take the dou by dou x by dou x is equal to 1, you have to get it, is equal to 0. Now you have to simplify, 2 1 ja, 2 1 ja get cancel. Now you have to, again you have to differentiate. What will happen? You have to see, you have to, no need of this one you won't write here, x dot, 2x dot only, sorry, 2x dot only you have to take, right? Again you have to differentiate m, you have to take m outside. Which one you have to write? D by dt of x dot by x, you have to take here x square u by v differentiation, x square u by v into x double dot minus x dot into x dot you have to take, right? Minus m x dot square is divided by 2, minus into minus plus, into x square plus 1 by 2 k is equal to 0. Now you have to multiply here m x into x double dot minus m x dot square is divided by x square plus m x dot square is divided by 2x square plus 1 by 2 k is equal to 0. Next you have to simplify here. How take the LCM? 2x square you have to take the LCM. 2x square means 2 into m x double dot, right, minus 2 into m x dot square plus m x dot square plus kx square is equal to 0. So which one you have to take the common? You have to take the 2, you get the cancel. Where is the common is there? X is the common is there. 2m x double dot minus here m x dot, here x is there, no, not x is there. So that's why you have to take x into x double dot plus, not plus, this is the minus. Which one you have to take here? X into x double dot, this one is x only. How to take here 2x square, you remove this one, here 2m x double dot minus m x dot square plus kx square is equal to 0. This is the Lagrangian equation of motion. This is the 5 marks question. That's why this lengthy question they are asking. Sometimes classical mechanics is lengthy only. You have to solve it, then only you will get the answer. Now you have to check for the answer. Which answer it is? So this one is the option C is correct. What is the 2m x double dot minus mx dot square plus kx square is equal to 0. Once you have to check here, 2m x double dot minus x dot square plus kx square is equal to 0. This is the, if you gave the Hamiltonian, then we have to calculate the Lagrangian like this. If you know the formulas, you go for the mathematics, lastly answer will come, but you have to do the calculation with carefully, then only you will get the right answer. Otherwise, you will get the wrong answer also. Now I am going to the seventh one. Seventh segregation we have to see. The time period of a particle of mass m undergoing the small oscillation. This is question belongs to periodic oscillations. Around x is equal to 0, in the potential V is equal to V naught cos x by L. V naught cos x by L. What they are asking? Time period they are asking. How we have to calculate? This question every time in every exam, whether it may be GATE, whether it may be CSIR, any exam this question will come. How we have to approach to find the time period from if the potential they will give. First we have to calculate, first you have to follow. There is a principle is there for equilibrium point. Potential is equal to V0 cos h of x by L. For equilibrium point, which one we learn, Nana? Equilibrium point, first derivative of this point, dv by dx is equal to 0 for equilibrium point. First you have to derivate the first derivative. For equilibrium point, dv by dx is equal to 0. First you substitute dou by dou x of v naught into cos x by L. How much value you will get it, Nana? V naught is the constant value. You bring outside. Cos theta differentiation is equal to sin theta sin h x by L. Again you have to differentiate x by L. 1 by L you have to get it. Therefore, which one we are getting? We are getting the value dou v by dou x is equal to v naught by L into sin h x by L we are getting. But we know one thing, the propagation constant k is equal to, dou square v by dou x square. But we know one thing, which one we know? So the propagation constant k is equal to dou square v by dou x square. D by dx of, which one we have to write? Dou v by dou x. Already we found d by dx of dou v by dou x is equal to v naught by L sin h x by L, right? Now you have to do, again you have to do, which one we are getting? Again you have to take v naught by L is the constant, cos h x by L. Again you have to differentiate x by L. 1 by L you are getting, right? V naught is divided by L square into cos h x by L is there, which is equal to k is equal to. But when at x is equal to 0, equilibrium point, at x is equal to 0, when x is equal to 0, this value belongs to k value. So therefore, at x is equal to 0, therefore k is equal to v naught by L square into cos h 0 by L is equal to cos 0 is equal to 1 v naught by L square, k value we are getting. Which value we are getting? K is equal to v naught by L square we are getting. But you know, angular frequency omega is equal to, omega square is equal to k by m, correct? Angular frequency omega square is equal to k by m. Omega is equal to square root of k by m. Therefore, omega is equal to 2 phi by t. Now only we discussed square root of k by m. Right? T is equal to, which one we have to write, Nana? T is equal to 2 phi into square root of m by k. Therefore, T is equal to 2 phi into square root of m is divided by V naught by L square, k is equal to V naught by L square. This value denominator by denominator goes to the numerator. T is equal to 2 phi into square root of ml square is divided by V naught. This is the time period. Like this we have to calculate. You go any exam, whether it may be CSIR, GATE, this type of question must be there. K is equal to, what is the nana K is equal to? So, K is equal to, at x is equal to 0. At equilibrium point, dou square V by dou x square is equal to K. What is your answer? Once you have to check here. So, which one is there? ml square by V naught. C is equal to 2 phi into ml square by V naught. This option is correct. Option C is correct. When they are asking 2018 June CSIR people are asking this question. It is very, very important. Easy also. If you know, it is very easy. Right? Now, 8th one. The half-life of an elementary particle moving with speed 0.9 c in the laboratory frame 5 into 10 to the power of minus 8 seconds. Then the proper half-life time is there. This question belongs to the special theory of relativity question. It is a proper time, right? There is two concepts are there in special theory of relativity. One is the time dilation, another one is the length contraction. Time dilation. Suppose a laboratory frame, center of mass frame is there. One frame is, if you have to move with the velocity of the light, what will happen? Your time should be expanded. If you move with the velocity of the light, your time is expanded. If you move with the velocity of the light, your length is contracted, right? Your length should be contracted. Your time should be expanded. What is the expanded time they are asking? How they are asking, Nana? Improper time, there is a relation is there. Improper time is equal to gamma into proper time. It is expanded, no? Gamma into proper time. What is the gamma? Gamma is the coefficient of relativity 1 by square root of 1 minus v square by c square. How much velocity is the particle moving? V is equal to 0.9 c. V is equal to how much? 0.9 c. Now you have to substitute. Improper time we want to calculate. Therefore, improper time is equal to 1 by square root of 1 minus v square by c square into proper time. Proper time. You have to substitute all the values. How much proper time they gave? 5 into 10 to the power of minus 8 seconds. Therefore, 5 into 10 to the power of minus 8 seconds into 1 by square root of 1 minus 0.9 c whole square is divided by c square. Right? 5 into 10 to the power of minus 8 into 1 by square root of 1 minus 0.9 whole square. 1 minus 0.9 whole square. Therefore, you have to calculate this value. This 10 to the power of minus 8 already is there. 5 is divided by square root of 1 by 0.81. 0.81 is equal to 5 is divided by square root of how much you will get? 81 means you subtracted from the 1 you have to get 0 point some value you have to get it. So you divided that value, you are getting one numerical value. That numerical value you have to enter here. How much numerical value you are getting, Nana? You are getting the numerical value. That value is 2.18. 2.18 into 10 to the power of minus 8 seconds you are getting. This value you will get it. Clear? Like this we have to calculate. This question belongs to which area? This question belongs to special theory of relativity. Very, very important. Sometimes they may ask Lorentz transformation. Sometimes they may ask Einstein energy principle. Sometimes they may ask velocity addition. Sometimes they may ask Galilean transformation. Any question they can ask, you must be prepared all the syllabus. I took one question. If you interested, you take my course and listen my classes, right? Now you have to see ninth one. Let A and B and C are the functions of a phase space variables or coordinate and momentum mechanical system. This is the Poisson bracket, represent the Poisson bracket. The value of A, B, C and minus A, B, C is how much they are asking. What is a Poisson bracket? Once you have to see the Poisson bracket, Jacobi identity is there. From the Jacobi identity, Poisson bracket identities are there. From the Jacobi identity, Poisson bracket of A comma, Poisson bracket of B comma C plus Poisson bracket of B comma, Poisson bracket of C comma A plus Poisson bracket of C comma, Poisson bracket of A comma B, Poisson bracket of A comma B is equal to 0. Now you have to, this is the, which one it is? Jacobi identity, right? From this Jacobi identity, what we have to get? A comma B comma C as it is there, as it is you have to write. Poisson bracket of A comma B comma C, Poisson bracket. There, what is there, Nana? AB comma C. AB comma C means you have to reverse it. Minus Poisson bracket of AB comma Poisson bracket of C plus which one we have to take plus as it is you have to write Poisson bracket of B comma C comma A is equal to 0. But which one we want to get? This value we want to get. This value is equal to, how we have to write? Poisson bracket of B comma C minus A comma B comma C is equal to, you have to write it is a minus. Minus means which one? C comma A. I am changing and writing. Once you have to see. So Poisson bracket of C comma A comma B we have to write. Which one answer? C comma A comma B. So option D is correct. Poisson bracket of C comma A B. How simple it is. Very, very simple. 5 marks question they are asking. This is a 5 marks question. When they are asking 2013 CSIR exam, people are asking. If you know the concept, you able to substitute in that formula, definitely you will get the answer. But you have to exercise it to get all these things. Not easy. It is a very, very big task to identify the things. You memorize the formulas, you remember the formulas, then how to apply your formula also you come to know. That is the thing. Last area. This area is a very, very important area, right? This area is very, very important. This is a last area. Which area it is? See, the relation between the Hamilton's principal function S, the Hamilton's characteristics function W for a conservative system. What is the relation they are asking? This question came Telangana State Eligibility Test 2017. It's a very, very important. This question belongs to Hamilton-Jacobi principle. From that question, that's why I took this one. Now, once you have to see, there is a relation is there. Which relation is there? The Hamilton's principal function Q comma P comma T, the Hamilton's principal function Q comma P comma T, S is equal to, this is a Hamilton's principal function, is equal to, what we have to write? Integral L dt. This is a, S is equal to integral L dt, this least action principle. Least action principle. This principle we also call it as a least action principle. From this least action principle, I want to get the answer. How we have to get the answer? Once you have to see. From the least action principle, S is equal to S q comma p comma t. It is a Hamilton's principal function. Which function it is? Hamilton's principal function. You have to take as a Hamilton's principal function. From Hamilton's principal function is equal to integral L dt. But L is a Lagrangian, you know. L is equal to summation of I, Pi, Qi dot minus H. You have to substitute there. S is equal to means you have to write here S of Q comma P comma T is equal to integral of summation of I, Pi, Qi dot minus H into dt we have to take, right? Now you bring the value, so two values are there. You take inside these two values, what you are getting once you have to see. S of q comma p comma t is equal to integral summation of I, Pi, Qi dot into t minus integral, which one we have to take? H into dt. But you know, Hamiltonian is nothing but energy eigenvalue, right? So S is equal to Q comma P comma T is equal to, this one is, we have to write a Hamilton's, which function it is? Characteristics function, W. We have to take Hamilton's characteristics function Qi dot minus E into integral dt we have to write. Therefore, the Hamilton's principle, this function is Hamilton's characteristic function. Hamilton's characteristic function. Hamilton's characteristics function, W of Qi is equal to integral summation of I, Pi, Qi dot into dt. Therefore, S is equal to W minus E into integral t is equal to t. This is the relation between S is equal to W minus E into t. What is the relation? S is equal to W minus E into t. This is the relation between the Hamilton's principal function S and Hamilton's characteristic function W. Energy is a conservative energy, that is the eigenvalue, Hamiltonian energy. Hamilton system should be conservative. Like this 9 areas I told. Once again I am informing you. So this is my CSIR and GATE batch. Will start from 7th January 2024. 7th January 2024 onwards, our batch will start from live come recording classes. Live come recording classes. Timing is 6 AM to 8 AM. 6 AM to 8 AM, right? You go to the Play Store, not Apple Store, right? You go to the Play Store, you download my app, that is Quantum Online Academy app. You have to download. You download my app. From that app, you have to join the course, right? Join in the course. You have to listen my classes. Their uploaded classes also will be there, but those classes must be purchasable, right? You have to purchase the course, then you listen the classes in your home only. The purely online mode. Okay, so wherever you may be, you are India or in abroad, you are other states, whatever it may be, any state, any person, if you want to aspirant for CSIR GATE physical science, you have to take my course. It must be helps 100% pakka, right? 100% pakka you will get CSIR or GATE or any competitive exam concerning the physics background, right? So this is my numbers. If you have any doubt, you consult me. This is my personal number 9908437460. This one is my institute number 630. My institute number is 630-326-3368. Right? You contact me. My personal number also 9908437460 also. A purely online mode, not offline mode. You have to take. You have to download my app Quantum Online Academy from Play Store from 7/1/2024 onwards. Maybe next month, maybe 1 month is there. Thank you. Right. Now, please share and thank you. Please share and subscribe to your friends. Maybe your friends may get benefited to listen my videos. I will continuously upload in YouTube also, not all. Some important topics I will upload, not all. Right. So, if you want to get all the subjects, if you want to crack the CSIR GATE examination, if you like my teaching, if you like my teaching style, then you have to take my course from the app store. That is a app only, Quantum Online Academy app. From that app only you have to listen, right?